Hi, this is Debdoot Roy Chowdhury, and in this video we are going to talk about Deque. So Deque is actually a container in standard template library of C++, and it exactly behaves like both queue and stack. Okay, the name may suggest that it is actually a queue, but it actually behaves like both queue and stack. So what is a queue? A queue is a container where you insert element from top, and if you remove an element, it will remove the first element you inserted. So it is actually sometimes called last in, first out. Okay. And if we talk about stack, what stack does is it inserts element at the top, and it also removes the last inserted element, the top element. Okay, this is queue and stack. So this Deque actually functions both like this. So to use it fast, we have to include its header file. So you have to include Deque like this, and obviously you can also just bits std use this header file. It will include all the containers and algorithms in the STL. Okay, so we'll first discuss all about this operations and declaration, then we'll see its implementation in action. Okay, so how do we declare it? If you want to declare it, you have to first say like Deque, then you have to mention the data type you are going to store in this Deque, then the name of the Deque you are going to go. Okay, and also you can insert element 1, element 2 like this. You can assign values like this. Okay, here you can see an example. We declared an int variable but didn't assign any variable, any data. You can actually assign data after the declaration, but here we see we assigned values 1, 2, 3, 4 here while declaring. Okay, so what are the operations it can offer? One operation, obviously push front. What it does is pushes it pushes at the top of the list. If it is a list like this, so you can say if this is a list like this, so it will push one element to the top of the list like this. And if you say push back, it will push back elements from back. See, like this. You can add elements from front, you can add elements from queue, both like stack and queue. Okay, and we have pop front, which will pop the last inserted element at the top, and obviously we have pop back, which is the last element of the list. It can also pop it like this, pop like this. Okay, so here is an example. See here, we have 1, 2, 3, 4 queue. We declared and assigned 1, 2, 3, 4, and we have something like this, right? 1, 2, 3, 4. So then what we did, we push front. We pushed 6 at front. See, this is 6, 1, 2, 3, 4. Here 6 is added here, and now we pushed 5 at the back. See, 5. So we pushed like this 5. Now we pop front, so it will delete the front element. Front element is 6, right? So it will delete 6. Now we have 1, 2, 3, 4, 5. Then we pop back, so it will delete the last element. See, back to this thing, 1, 2, 3, 4. Okay, so there are other functions like front. So it actually returns the first element of the Deque container, and also back, last element, reference to last element of the Deque container. And there is also an insert function. Insert function actually inserts element before the position of this iterator. So if we say it like this, 1, 2, 3, and we created an iterator of the begin function, and we increase the iterator to plus plus. So our iterator now mainly points at 2, right? Here iterator points to 2. So if we insert 5 and we mentioned it comma 5, so it will insert 5 before this iterator. See, 5. And obviously this iterator, this function will return an iterator, which is the newly inserted element. Okay, so the iterator will now point to this it because we changed it here. Okay, then there is size. See, so what size does, it returns the current size of the Deque container. So if we have 1523, if we use size, it will return 4 hours. 4 is the size of our container. Okay, let's see all these functions in operation. Okay, so we first include its header file, include Deque. Okay, then we declared a Deque of name q, and we inserted elements 1, 2, 3, 4. Okay, now we printed this. See, 1, 2, 3, 4 is our element. Okay, and see push front, we are pushing 8 at the front, so that see 8, 1, 2, 3, 4, 8 is pushed at the front. Okay, then we pushed 9 at the back. See, 8, 1, 2, 3, 4, 9. Okay, and then we popped on the front. See, 8 is 8 is not here, 8 is deleted, and we pop from the back. See, 9 is deleted, 1, 2, 3, 4, back to same again. Okay, see, if we return the front element, see, 1. If we return the back element, 4. Okay, and next we have insert function. If we insert after this iterator, what is this iterator? Iterator was q.begin. So our beginning element was our iterator 1. Then we we incremented our iterator by 1. So our 2 is our next iterator. Then we inserted 5. So what will happen? 5 will get added before 2, because 2 was our iterator, 5 added, and obviously it also return an iterator. You can store it. Okay, that's it. If you run this, see, 1, 5, 2, 3, 4. Okay, so this is actually the operations in action, but you may ask that how actually this Deque works. We'll talk about it now. Deque actually provides both push and pop like stack and queue, and in constant time. So it provides push pop at both ends in constant time, and it also provides random access of elements like an array, not like a linked list. So you may think that in a linked list you can push and pop from both the end using pointers, but if you want to reach the end of the node, if you don't have any tail pointer, it will take almost linear time. So but in Deque we can do that in constant time. How? So what happens when you declare a queue like this? So you have like 10 data. See, yeah, 10, sorry, 11 data. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 11 datas, and they are actually divided into chunks. Okay, the first chunks, the foremost chunk actually have datas like this. So it has empty space up above. So if you want to push data at the front, it will get added here. And if you want to push back at the end of the queue, it will add here. And obviously this is our begin iterator, and this is our end iterator after this. So it will get shifted from one position, and this will get shifted to one position if we add elements at the push and from. And this chunk is actually stored like this: chunk 1, chunk 2, chunk 3. Basically the middle chunks are almost full, only the upper element, only the upper chunk and the lower chunk are actually half filled. So if you add, it will get filled, and when it gets almost filled up, another chunk is called in action, like this, simple like this. So in this way we can provide both push pop in constant time.